What if you could develop land with less street, larger living spaces, eliminating the monotony typical of development while increasing the function, connectivity, safety, and real estate value of land development? For the past 5 decades, we've been pioneering new land surveying and civil engineering technology. We've used that technology for the past 3 decades to discover new methods to develop land and build homes. I'll give you a few examples of how these have benefited not just the land developers in the cities, but most important, the people who live in these developments. What makes these methods unique is that we don't follow the ordinance minimums, but instead we increase the dimensions from regulatory minimums. And in doing that, we're able to gain efficiency. So that way, when we go into a city, we don't have to ask for smaller and smaller and smaller lots. We do the opposite. We actually give more space, but make the development more efficient. One example is Tres Lagos in McAllen, Texas. The original plan had 5 miles more major collector streets. What this means is the 79 acres that would have gone to collector streets is now used for residential development. Within the pods, we have about 20 to 30% less street length, which makes those lots even bigger. We're not gaining density, but we're reducing the cost of development, the volume of pavement and utility mains. So we're not reducing the right-of-way or the pavement. We're working on street length with these new models of development. To achieve better pedestrian connectivity, other planning methods would have you build more street so that you would have more sidewalks. We do the opposite. Instead, what we do is we design the main trails first, and then we design the neighborhood around it. For better vehicular connectivity, we're looking at flow. How long does it take to go through a neighborhood? And when you have a lot of stops or intersections and turns, it adds quite a bit of time and it uses a lot of energy. We use a Main Street approach, which creates a neighborhood identity, maintaining flow through that main street to significantly reduce time and energy as you go through a development. The typical development that we have designed has a demonstrated 25% reduction in street length. Now, every development is different, so maybe it's only 5% of one development, or maybe it exceeds 50% in another development. Every development is going to be different. It doesn't necessarily mean it's going to be 30% less cost to develop land, because there are some costs that go up. But in the end, you're going to end up with a much more beautiful and exciting neighborhood that certainly isn't going to cost any more than if you were to develop on a conventional method. But the key thing is we're working with real numbers here. A 20% reduction in street length is 20% reduction in the length of sidewalks that go along the street. It's 20% reduction in the utility main. So in other words, we're reducing the right-of-way that would have otherwise been dedicated to the city, and we're putting it into sellable lots. So instead of the developer buying, like 40 acres and giving 10 of those acres back into the city and say, here's your streets, maybe we could reduce that 10 acres to 7 acres, and then that 3 acres is then spread out through an individual ownership to increase the property values. So from a city's perspective, the cost of maintaining all that infrastructure plummets, and from the developer's perspective, the value of the lots increase, and then from the city's perspective, because you have higher value real estate, what you've got is more tax base. If you look for the past 100 years, from an architectural perspective, about every 10 years, about every decade, there's a new architectural facade or model. For example, in the 20s, the homes had a beautiful big front porch, and because there's no air conditioning. But what happened is around the 30s and 40s, you saw the porches disappear, and people wanted to live in their private spaces in their backyard and not be so social in their front yard. And then in the 60s, you had the homes got wider, the 2-car garage, the 70s and 80s, the 3-car garage. In fact, the 70s and 80s, the home was garage, and then the home hid behind the garage in a lot of these models. And now we're coming into an era where we're going back to a front porch look, but the homes are still oriented to the back. So that means that you've got this front porch, but nothing really pushes you to that front porch. You might notice that decade by decade facades change, but when you look at the interior floor plan of a house, for the last half century, it's hardly changed at all. But what if the concept would be, when you're designing a home and you're designing the neighborhood, if you have all this new open space around the home, why aren't you designing the interior floor plan, the walls and the window placement, so that when you're in the home, you enjoy that extra space? For the past few decades, where we've really made progress is in this merging of architecture and planning to create a higher form of residential living. It began with a unit we call the bay home, which is essentially a rear-loaded, narrow but deeper single-family home, full front porch, staggered so that living spaces get a panoramic view of common space and not looking over a street with parked cars. This method significantly plummets the amount of pavement and the cost of development while increasing green space and increasing density while still providing a suburban sense of space. Another architectural method that we pioneered is called architectural shaping. For example, this is Trisona in Vieira, Florida. Every home is shaped because we're holding a constant angle between the two lot lines. That means a home can get wider in the front or wider in the rear. And we brought that up to address the narrower 35-foot and 40-foot wide products. But Vieira builders decided to throw out all of their floor plans and start fresh to have it on all of the 1,350 homes that they built in Trisona. And we demonstrated a 38% reduction in street length compared to the previous plan. And this added 19.3 acres of usable land in the north section of this neighborhood alone. In Water Lily, within La Siena, we used the same bay home model, but then we started using the side yard for private patio space and parking. And that allowed us to reduce the space garage to garage and then increase the space not where cars park, but where people park. This method allowed us to increase the density and increase the open space. And even on my own development in Rochester, Minnesota, the Ponds of Highland Hills, we used that same model and brought that model to Minnesota. Now, none of this would have happened if we used the same CAD-based products of every other consultant. So for the past 2 decades, we've been developing what we market now as Land Mentor. 22 years ago, I sat down with my programmer and we said, why can't software be easy to use in civil engineering and surveying? We eliminated commands. CAD has thousands of commands. We have none. We wanted to make a user interface that was fun to use while expanding the capability beyond CAD for land surveying, civil engineering, planning, architecture, and much more. When was the last time as a land developer or even a city that you saw 3D as a normal deliverable? In this era, we're still looking at 2D plans nobody can understand. So 22 years ago, Keith and I decided to use video gaming for the basis of our software 3D. So the trick is to go from a seamless 2D working environment into a 3D environment with the least effort. And every site that we design, we deliver 3D at no extra charge. But not just 3D, we deliver it in a format that the clients could just click a file, open it up, and they could play their site just like a video game with using an Xbox 360 to move about the site, go in the homes, look out the windows, and experience what they are. But more important, they could don a VR headset and they're no longer looking at a 2D plan or a screen in 3D. You're projected into the development, and we were the first on the planet to use virtual reality in public meetings. But that's not what the cool thing is about Land Mentor. When you look at the colors and the textures and the detail that we deliver, each one of those colors and textures represent a man-made element that we're adding to the ground. In a CAD-based system, to get this kind of data, you would take weeks or months instead of seconds or minutes added to the plan in Land Mentor. And that gives us the power to analyze the efficiency of a plan and report it. So we've developed a technology that doesn't take months or years to learn. It takes days or maybe a week to learn. And this includes all of the civil engineering, surveying, planning, everything. We could reduce the learning curve. Instead of schools teaching months or years of a degree on how to use CAD, they can now take that time to teach people to think differently and think better and replicate some of the benefits that we've brought to the development industry. I believe that we can create a new generation of planners, architects, engineers, and surveyors that are better equipped to create better communities for everybody in this world. And I just don't mean better by having more space or views, but better because less infrastructure is less environmental impact, it's less cost, and it solves a lot of issues and a lot of problems. There are roadblocks. For example, you can have some software that designs the neighborhood in just a matter of minutes, if not seconds. And this is why we have developed the methods, the technologies, and the training, not just for consultants, but for developers and builders to make better decisions, for cities not only to make better decisions that could significantly reduce their infrastructure, their cost of maintenance, and increase their tax base while helping solve the affordable housing situation. And instead of looking at a 2D proposal that nobody understands using drafting standards from the 1800s, we can empower cities with VR systems and better technology so that when a proposal comes in, they can communicate to a developer, hey, you're building an extra mile of street. You don't want to spend extra $5 million on that street, and we certainly don't want a mile extra street to have to maintain forever. Why don't you take that right away, put it in your lots? But cities don't have that feedback because they don't have the technology that we developed and they don't have the training that we developed, which opens up entirely new possibilities for the entire land consulting industry. Developers who pay the consultants need to understand this and hire consultants that want a new era instead of just blindly doing another gridded subdivision. But what goes in that ground is going to be there for hundreds of years and affect thousands and thousands of people. Something that's done quick instead of done right. Because that land plan is the developer's business plan and will make a major difference for the builders to sell their homes. So in conclusion, planning shouldn't be about social engineering. We shouldn't use the car as a scapegoat and say we're destroying the world because of the car, but as a result, for pedestrian connectivity, let's build a whole lot more street and make little tiny blocks so that we actually increase the cost of development and decrease the green space. We believe in the opposite. Create more efficient and better design. We increase the livability without increasing the cost. And we've been very fortunate that over 300 developers for the past 30 years have retained us to design 1,700 communities in 48 states and 18 nations. And the income from that has gone to develop this technology that could benefit the rest of the world, leaving a legacy that will last forever.